Hello and welcome to another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 10, Lesson 2 on scientific notation. Now this entire unit is actually called scientific notation. And this is a system by which scientists represent very large and very small quantities using powers of 10. So let's start to investigate that system. Now it's very, very important. We reviewed in our last lesson powers of 10, and we're going to look at them again in exercise 1, okay? But it's pretty important that you saw that lesson or that you've had some basic work with powers of 10, both positive powers and negative. Now, scientific notation gives scientists and engineers a way to write very large numbers or very small numbers in a compact way. The idea being that I don't really want to have to write out something like 7 trillion with 7 and 12 zeros after it, right? I don't want to do that. The number would take up this much space on a paper. So scientific notation allows us not to have to do that. Before we do that though, let's review in exercise 1 our work from the last lesson on powers of 10. Write each of the following products by moving the decimal place accordingly. All right, so what I'd like you to do is pause the video now and actually write out each one of these things by moving the decimal place in whichever direction the power of 10 indicates, and then let's go over it. All right, so here we have 5.7 times 10 to the third. Because that's a positive power, it indicates what I should do is take that decimal place and move it 3 units to the right, filling in my missing places with 0, and we have 5,700. Okay, now let's take a look at one with a negative power to it. All right, here I've got the power -2, and that power is going to indicate that on my 6.3, I should move my decimal place 2 units to the left, giving me 0.063. All right, so letter C, 8.13 times 10 to the 6th. Again, nice positive power, 10 to the 6th, meaning I should move my decimal place 6 units to the right. So 1, 2, 3, 4, 5, 6. Filling in these with zeros would mean that I'd have 813,000, 8,130,000. And our final power, 10 to the -5, right? That means that I've got to move that decimal place 5 units to the left. 1, 2, 3, 4, 5. Pardon me for getting in there. And that's going to be 0.000314. I try to sneak an approximate value of pi whenever I can. Okay, so again, think about this for a moment before we move on. Right? When I've got a positive power, like 10 to the third, I end up getting a large number. And when I have negative powers, like 10 to the -2, and even better, 10 to the -5, I get very small numbers. And again, I very, very much hope that you recognize that these are very small numbers. I'm betting that you have no problem realizing that 8,130,000 is a large number, and 5,700 is a relatively large number. But sometimes with small numbers, students, very understandably, think of small in terms of numbers like 1, 2, 3, 4, right? But I'm really talking about numbers that are very close to 0. Very, very close to 0, much smaller than the number 1, right? Much smaller than the number 1, but haven't gone negative or anything like that, okay? So now, let's start to go in the opposite direction. That's what we're going to be working on today. Now, what do I mean by the opposite direction? I mean taking a number, okay, and then writing it as a product involving a power of 10. So we want to reverse what we did in exercise 1 and write the numbers as products involving powers of 10. So let's look at 2 examples. Exercise number 2. Consider the numbers 3,000 and 0.05, and remember 0.05 is the same as 5/100ths, okay? So let's take a look. Letter A, all right, says fill in the blanks of the following. Okay, so what I'd like you to do, this one's a little bit more challenging. See if you can fill in whatever blank should be here. So 3,000 is equal to 3 times what? And then that's 3 times 10 raised to the what? So go ahead and play around with that for a second. Pause the video now. Well, this should be a piece of cake, right? 3,000 is by definition 3 times 1,000, and 1,000 is just 10 to the third. So in other words, right, I can write the number 3,000 equivalently as 3 times 10 to the third. So in the previous exercise and in everything that we did in the last lesson, we were taking something like 3 times 10 to the third, and we were writing it as 3,000. Today's lesson, I want to go in the opposite direction, which is take a number like 3,000 and write it as 3 times 10 to the third. Now, that's not too bad with a number like 3,000. This is a little bit more challenging, right? Here, I have 5 100ths. Now, see if you can fill in the blank down here in the denominator and then the blank up here in the power of 10. Pause the video now. Well, especially if you know that what we call this is 5 100ths, then it's not that hard to see that the blank down there should have a 100 in it. Now keep in mind that 100 is the same as 10 squared, right? So 0.05 is the same as 5 divided by 10 to the second power, which means it's the same as 5 times 10 to the minus 2 power. All right? And again, I want you to think about this for a second. Equality means these are the same things. So I could really check this answer by saying if I was given 5 times 10 to the minus 2 and I wanted to write it as a decimal, what would I do? Well, I'd take the decimal and I'd move it 2 places to the left and I'd have 0.05. Same thing here. If I had 3 times 10 to the third and I wanted to write it without the times 10 to the blank, I would take the decimal and move it 3 places to the right, and I'd have 3,000, okay? So our whole purpose today is going to be to go in the reverse of what we did in the last lesson, to take a number and actually write it as a number times 10 raised to some power. Let's keep going with this idea. All right, we can actually write any number whatsoever, no matter how large or how small, as a product of a number between 1 and 10. That's critical. A number between 1 and 10, that could be 5, 7, 3, 2.8, 7.1, 3.25, any number between 1 and 10 and an integer power of 10. All right, so let's play around with that a little bit in exercise number 3. Write each number below as the product of a digit between 1 and 10 and a power of 10. All right, great, right? This isn't that hard. You know, like the number 70, right? I could do that with the number 70 by first thinking to myself, well, that's 7 times 10. All right, and literally I would be done. Now, maybe just for kicks and grins, maybe I'll write that as 7 times 10 raised to the first. I like to see that sort of, that power sitting there. I don't have to technically do it, but that's basically it. You know, it's like 7 times 10 to the first. How could you write 200? Pause the video now and try to write that as some number between 1 and 10 times 10 raised to some power. Pause the video now and go ahead and do it. All right, well, again, pretty easy, because 200 is just 2 times 100, and 100 is just 10 to the second power. So 200 could be written like 2 times 10 to the second. And look, I really, like these two numbers are the same. 200 and 2 times 10 to the second, they're the same number, they're just written differently. Now for the harder ones, right? So these are ones that have positive powers, but now we've got ones that have negative powers. Let's take a look at 0.9 together. Now 0.9 is 9/10, right? Just think about this for a second, right? If you had to write that back when you were first learning about decimals, that would have been in 5th grade, you know, you would have had to write 0.9 as a fraction. Well, that's 9/10. So what does that mean? That really means we've got 9 times 10 to the minus 1, right? We are dividing 9 by 10. once. And that's it. All right, do a little bit of a challenge and see if you can do letter D. Now, as an aside, you can check whether or not your answer to letter D is correct by simply doing what we did in exercise number 1 and what we did the entire last lesson, right? So once you get your answer like this, ask yourself, if I was given this to begin with and I moved my decimal place, would I get that back? So play around with that a little bit. Pause the video now. Well, 0.003 is 3 1,000th. All right, this is the same as 3 over 1,000, which is the same as 3 times 10 to the negative third, right? Now, can I check that? Sure, I could check this, right, by taking that 3 and saying, well, all right, I would move that 1, 2, 3, and yeah, right? It would be the right answer. Okay, so anytime I ask you to do this, you can see whether you're right or not by just doing what we did in the last lesson. Oh, okay, well, if I move the decimal one way or another, right, I can check to see if I've written it correctly. Now, believe it or not, what we've done in each one of these exercises is we've placed the number, which is just our normal decimal representation of the number, into what's known as scientific notation. So let's formally introduce the idea of scientific notation now. Writing a number as a product of a number between 1 and 10 and an integer power of 10 is known as putting it in scientific notation. When a number is written in the form of a times 10 to the n, where a is a number between 1 and 10 and n is an integer exponent, positive or negative whole powers, right? That is scientific notation, all right? That's all it is, okay? Now, let's kind of play around with this a little bit. Okay, now scientific notation, or putting a number in scientific notation, is literally just going in the opposite direction of what we did in the previous lesson. But that can still be challenging, so let's play around a little bit more. Let's take a look at exercise number 4. Consider the numbers 4.82 times 10 to the 5th, that's actually a number written in scientific notation, and 527,000, that's a number just written in normal decimal expansion. So letter A asks us to write 4.82 times 10 to the 5th without the use of exponents by evaluating the product. Great. So letter A is exactly what we did in the last lesson, exactly what we did in exercise 1 today. Why don't you go ahead and do that? All right, well, so what does this tell us to do? 4.82 times 10 to the 5th tells us, oh, we should take our exponent and move it 5 places to the right, giving me 4, 8, 2, 1, 2, 3, giving me 482,000. Now notice I moved that decimal place 5 places to the right because that's what the power of 10 tells me to do. Now, I need to somehow in letter B do the opposite. Let's take a look at what we're asked to do. Write 52,700 in scientific notation by reversing what you did in A to determine the exponent. All right, so I want you to play around with this a little bit. Now, all right, here's a little bit of hint. At the end of the day, you're going to have an answer that should look like this. 5.27 times 10 to something, right? The question is, what is that? Now, how do I know it's 5.27? Well, we have 527, so we've got to have those, all right? And the number that's between 1 and 10 is going to be 5.27. If I had 52.7, that wouldn't be between 1 and 10. If I had 0.527, that wouldn't be between 1 and 10. So the question is, what should the exponent be? I'd like you to pause the video now and play around a little bit with that. Well, you can just kind of guess and check, you can play with it, you can do all sorts of things, but ultimately, here's how you can figure out that exponent. Right? Now, we know it's going to be a positive exponent, and we know it's going to be a positive exponent because in order to take this and multiply it by something and get this, we'd have to move the decimal place to the right, and that would tell us that. The question is, how many places would we have to move it to the right? Well, we can think about that by taking this number and going 1, 2, 3, 4, right? And that's how many we would have had to move it to the right had we been given this in the first place, right? So again, think about it for a moment, right? I know it's going to be 5.27 times 10 to the something. And when I multiply it by, 10 to the something, that would have to leave me with this answer. So I actually reverse and I count how many times it would take me to move that decimal place so that I have a number between 1 and 10, and then that becomes my exponent. Now, you don't have to take my word that it's 10 to the 4th. You can now take this thing and say, oh, well, if they gave me this to begin with, kind of like in this problem, and I then moved my decimal place 4 to the right, 1, 2, 3, 4, I would end up having that number, all right? But the key is to literally reverse what we just did. The thing that gets a little bit tricky is, should it be a positive? Should it be a negative, right? In this case, right, it's a positive exponent because ultimately, right, I moved the decimal place to the left to get that number between 1 and 10, but then the product should give me that large result. So let's keep working with this, because this is not hard when you first kind of work with it, or it's not hard once you get used to it, but it's a little confusing at first. To write a number in scientific notation, we must reverse what we did in the previous lesson when we multiplied by powers of 10. Always remember the following about numbers written in scientific notation. Large numbers, thousands, millions, billions, trillions, will have positive powers of 10. Small numbers, 1/10th, 1/100th, 1/1000th, 1/1,000,000th, those will have negative powers of 10. Okay? So let's play around with that and see what we can do. All right, now we're going to start with just positive powers of 10. Exercise number 5. Rewrite each of the following numbers in scientific notation. All powers here will be positive. Check mentally. All right, we'll talk about that check mentally thing here. So I want to write 570 in terms of scientific notation, okay? So here's how I'm going to do it. I'm going to take my 570 and I'm going to reverse what I did in the previous lesson. I'm going to say, all right, well, I'm going to move this to the left 1, to the left 2, and I'm going to get 5.7 times 10 to however many steps I had to move it. So 5.7 times 10 to the second. Could you have 5.70 times 10 to the second? Absolutely. Nothing wrong with that. But that extra 0 that would hang on after the 7 wouldn't give us anything. It wouldn't tell us anything. Now, how do I check this mentally? Well, I check it mentally by saying, well, now, if these two are equal, if I was given this and I multiplied it back out, I would move that decimal place 2 to the right, and I'd have my 570. Okay, let's do another one together. 26,400. Okay, if I want to write this in scientific notation, I'm going to take that decimal, I'm going to go 1, 2, 3, 4, and that's going to be 2.64 times 10 to the 4th, because I moved it 1, 2, 3, 4 units to the left. Now again, checking it mentally, are these two things the same? Well, if I took this product and I took the decimal and I moved it 4 places to the right, would it give me this? And the answer is yes, right? I'd move it these 2 places and then I'd get another 2 zeros, and that would give me that number. All right, you try it with letter C. All right, let's do it. So I'm going to go right from here. I'm going to take this decimal point. I'm going to go 1, 2, 3, 4, 5, 6. So that would be 7.143 times 10 to the 6th. And again, easy enough to check. If I now took that decimal place, if I asked you to evaluate this product, would you get this? Right? Well, I would move that thing 6 units to the right, 6 places to the right, and I would end up with this number. All right? Very big numbers, numbers that are, I shouldn't even call them very big, but numbers that are larger than 10 will end up, when written in scientific notation, with positive exponents, right? Positive exponents. It makes sense, right? I mean, if I had the number 100, it would be 10 to the second. 1,000 would be 10 to the third. Technically, in scientific notation, 100 would be 1 times 10 to the second. 1,000 would be 1 times 10 to the third, etc., right? Because I got to have that number between 1 and 10. All right, now let's go with the small ones. Now, all of these should end up having negative exponents. So, again, let's talk about how to do that. But first, let's read the directions for exercise number 6. Rewrite each of the following numbers in scientific notation. All powers will be negative. Check mentally. All right, great. So 0.027. All right, I want to literally go in the opposite direction that I did when doing the products. I'm going to move that decimal place 2 units to the right, and because I moved it 2 places, it's going to now be a negative exponent. So this is 2.7 times 10 to the negative 2. Now again, checking it mentally, I want to make sure that this number and this number are the same thing. So if I was asked to evaluate this product, I would move that decimal place 1 to the left, 2 to the left, and I'd have 0.027. Boom, it would work. Let's do 0.0009 together. All right, 0.0009. All right, I'm going to move 1, 2, 3, 4, right? And that's just going to be 9 times 10 to the minus 4th. And again, check mentally. If I had this thing and I decided I wanted to write it in just standard decimal notation, I would have that decimal, I'd go 1, right? That would be 0.9. Then I'd go 2, 3, 4. That would give me those 3 zeros and the 9, and I'd be all set. Try that with letter C. All right, that is a tiny number. See what you get when you write it in scientific notation. All right, I got to watch myself here. I really got to keep track. So here we go. 1, 2, 3, 4, 5, 6, 7. So that would be 7.83 times 10 to the minus 7. Right? And again, a little bit harder to check mentally, but you could still do it. You could say, well, I'd have to move that decimal point 7 places to the left. The first place would just move the decimal point to here, so it'd be 0.783, and then every other one would give me another 0. So I have 6 zeros and then 783. That's it. And again, think about it for a moment, right? Let's really kind of talk about this, and then we're going to get into some nice applications which are kind of cool, right? I don't want to write this number this way. I really don't, because all these zeros are just kind of obnoxious, right? This is a much more compact way of writing the number, and on top of that, right, as a scientist or an engineer or something, because it's 10 raised to a pretty big negative exponent, I know this is a very small number, right? I know it's quite small. 10 to the negative 7th is tiny, and if I have 7.83 of these 10 to the negative 7ths, you know, I don't have much at all, you know, whatever it is. So let's play around a little bit now with scientific notation. Now, scientific notation is used for a lot of measurements in the real world that are either very large or very small, okay? Because again, I don't want to write out all the zeros, you know, there's a lot of zeros. So let's take a look at some of these where scientific notation would make sense. Exercise number 7. The diameter of the Earth in feet is 41,851,000 feet. 41,851,000 feet. Write the diameter of the Earth in scientific notation. Use proper units. Cool. All right, so I mean, it's fine to write it that way. It's kind of nice because I can see that it's 41,851,000. But if I want to write it in scientific notation, right? Let me write the number in just normal notation. 41,851,000. Right? This is normal notation. Now, if I want to write it in scientific notation, I'm going to go 1, 2, 3, 4, 5, 6, 7. Right? So I'm going to have 4.1 4.1851 times 10 to the 7th feet. By the way, it's good to know off the top of your head, it's kind of good to know, that 10 to the 6th is a million, 10 to the 9th is a billion, and 10 to the 12th is a trillion. I don't know what happens after a trillion. Maybe numbers just end. Although you should look that up on Google, because I don't know, maybe after a trillion things just stop. Anyway, not the point, they don't. But I can look at this and go, man, that is huge, right? That is a big number because I got 10 to the 7th, right? And it's all about just knowing, if I want to write it in scientific notation, I just move that decimal point until it's between, the number here is between 1 and 10. All right, keep track of how many places I move it, and because this is a big number, that power is now positive, 4.1851 times 10 to the 7th. The Earth is pretty big, although eventually we'll also look at the diameter of the sun. Not in this lesson. Let's take a look at exercise number 8. That's something very small. A sheet of paper has the thickness of 0.00012 meters. Wow, that is thin. Write the thickness of the paper using scientific notation. So now we have a very small number, right? 0.00012. Very, very thin paper is. Now if I want to write this in scientific notation, whatever my exponent's going to be is going to be negative, right? And I'll figure that out by going 1, 2, 3, 4. So that's going to be 1.2 times 10 to the minus 4th meters. Right? Quite small. I think it's 12/100,000th of a meter. That sounds weird. This is actually nicer. 1.2 times 10 to the minus 4th meters. I see that -4 on the 10, and I know this is small. Okay, I'd like you to do a couple on your own. So number 9, we've got one that's a large number. Number 10, we've got one that's a small number. Why don't you try to do both of these in terms of scientific notation? Pause the video now. All right, I love number 9. So scientists estimate that the number of cells, the cell is the smallest building block of life, right? The number of cells contained in an adult body, like my own, although some people would dispute if I'm an adult, but in an adult body is around 30 trillion, which is 30 with 12 additional zeros stretched out in front of it. Write this number in scientific notation. All right, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's going to be 3 times 10 to the 13th, whoops, not times 10 to the 3rd, cells. 3 times 10 to the 13th cells in the human body. That's almost creepy. All right, let's take a look at one where we deal with something very small. Exercise number 10. The bacteria used to create yogurt are approximately 0.000003 meters long. Write the length of these bacteria using scientific notation. And again, the great thing is they're both going to be 3 times something, right? In this case, it's going to be a negative exponent. What's the negative exponent? Well, 1, 2, 3, 4, 5, 6. That's going to be 3 times 10 to the minus 6th meters long. By the way, if 10 to the 6th is a million, right, and it is, 10 to the 6th is a million, then 10 to the negative 6th is 1/1,000,000th. So the length of the bacteria that are used to create yogurt, called lactobacillus, are 3/1,000,000ths of a meter long. Tiny, microscopically tiny. We couldn't see them with the human eye. All right. So let's summarize, right? In lesson 1 of this unit, we took products that involved powers of 10 and we wrote them out in standard decimal expansion by moving the decimal place one way or another. If the power of 10 was positive, we moved it to the right, and if the power of 10 was negative, we moved it to the left, okay? In this particular lesson, we did the opposite and we introduced something known as scientific notation, which is taking any number whatsoever, but typically very large numbers and very small numbers, and writing them as a number between 1 and 10 times 10 raised to some power. Okay? We figure out what that power is in almost the opposite way that we did it in the first lesson. In other words, if we have a large number, we would have to move the decimal to the left until it becomes a number between 1 and 10. However many places we move to the left, that will be the exponent on the 10. And likewise, for very small numbers, we would have to move the number to the right, and however many places we move it to the right in order to get a number between 1 and 10, that becomes the negative exponent. Again, this can be a little bit confusing because it is literally the exact opposite of sort of what we did in lesson 1. But never forget, when you place a number in scientific notation, you can always check to see if it's right by literally rewriting it out in decimal notation. And if it becomes the number you started with, then you must have written it in scientific notation correctly. All right, well, obviously the whole unit is on scientific notation, so we're going to see it a little bit more in the coming lessons. For now, I just want to thank you for joining me for another NGen Math 8 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.